Yes, members. Hello? Are you getting? Okay. Can we proceed? Can we proceed? So let's proceed, please. Let's proceed. So, please, there's Beatrice.
Yes, teacher.
I'm getting
Yes,
a lot.
teacher.
There's a lot of noise in your background. All right. So before we went for the break, we are still looking at Newton's first law of motion. And we said one of the important aspects, we did that experiment. I believe you are all seen that you can read through, because the most important thing is the concept. Okay? So we have got the concept. So because once you know the concept, you can use it to explain any aspect now that come across. Now let's look at inertia. Let's look at inertia, which we have already even defined it already. Not so. So, but can you just put it down now? Can you put it down now? We are saying inertia is a tendency of a body to remain at rest or to continue moving in a straight line, or to continue moving in a straight line. Is the tendency of a body to remain at rest or to continue moving in a straight line. If you don't want to use the word tendency, you can use the word is the reluctance. You can use the word what? Reluctant. If you don't want to use those two words, you can use is the inability, okay? Is the inability. You can use the word inability. You can use reluctance. You can use the word reluctance, or you can use tendency. All means the same thing. Are you together? All means the same what? The same thing. So someone can say in inertia, inertia is the inability of a body to remain at rest or to continue moving in a straight line. Or someone can say is the reluctance of a body to start moving or to stop moving once they have started motion. Or someone can say is the tendency of a body. Just use one of those words. Right together. Don't use all of them. Pick one and use it, okay? Are you together? Members, are we together?
Yes, teacher.
Yes.
Yes. And I remember saying, it's for this reason, that's why we refer to the Newton's first law of motion. We said sometimes it's called what? The law of, sometimes it's called the law of inertia. Sometimes it's called the law of inertia. So a body of large mass required a large force to change its speed or its direction. So the body has large inertia. Thus, the inertia of a body is only affected only by one factor. What is that factor? I remember discussing that at that time. Inertia is affected by?
Mass of the body.
Is affected by mass of a what? Of a body.
Of a body.
So which means the bigger the mass or the larger the mass, the larger the what? The inertia, right?
The inertia.
Not so.
Yes, teacher.
Yes.
You see, that's why I like physics, because physics give answers to real life. It's like, now take for example, if your parent give you a 50 kilogram bag of cement to carry, can you carry that one with a lot of ease? Can you carry it? Huh? Can you carry a 50 kilogram bag of cement? Can you?
No.
No.
For you to carry it, you need a what? You need a lot of force, not so.
Yes.
Because the cement has a large mass, which means its inability to move is very high. It will remain at rest. Are you together? And that one also explains. That's why if you see heavy trucks, I've seen heavy trucks. This one moving around the heavy trucks. If they are moving at very high speed, it's very hard to stop. It's very hard to apply a brake. Have you seen that? It's very hard to apply what? A brake. For you to apply a brake, a car must be moving at a considerable what? Speed before you apply a brake. Are you together? Otherwise, if it's moving at a high speed and you apply a brake suddenly, the car may crash or it may cause accident, terrible accident. Are you together? Are you together, members?
Yes, teacher.
Yes.
So all those explanations I've given, they explain the Newton first law of motion and they explain inertia, right? Now let's move to the second. Let's move to the second law, which is the Newton's second law of motion. Newton, second law of motion. Newton's second law of motion. Newton's second law of motion. Newton's second law of motion explains the relation between a force applied to a body and the change in its momentum. Remember, we talk about momentum, right? Do you remember that? Momentum. We remember talking about momentum.
Yes.
Who remember that? Who can explain? Who can define for us linear momentum? What is linear momentum? Is there? What is momentum, members? Who can define for us momentum? Momentum is the product, okay? Momentum is the product.
Mass and velocity.
Product of
Mass,
Force of your body and velocity, product of
mass of the mass of body and its what? And its velocity moving in a straight what? Moving in a straight line. Okay?
Velocity.
Yes. So in a nutshell, we said momentum, okay? We use letter P. We use letter P for momentum, which is equals to mass and its velocity, right? Where M is the mass, M is the mass, then V is the velocity of the body.
Velocity.
Okay? And momentum is only affected by two forces. Momentum is affected by mass of the body and what? And velocity of the body.
Velocity.
Okay? So what Newton did, Newton was trying to look at the relation between the force applied and the change in momentum. And remember the other time when we were looking at one of the aspects that when there's a change in momentum, there's a force that we normally experience. What is that force? Is what we call what? Impulse. Do you remember that?
Impulse.
Impulse. And we said impulse is the what? Is the product of what? Is the product of force. Product of what?
Time.
Is a product of force of action, no sir? Is a product of force of action on a what? On a body and is what? And what? And time. Okay? Are you together? And we went ahead and said that change in momentum is equals to what? Is equals to what? Is equals to impulse. Change in momentum is equals to impulse. Is equals to impulse. Good. Now we are saying change in momentum is equals to impulse. But we know that impulse, we said is a product of force and what? Time, which is going to be Ft, right? Is Ft. So it implies now Ft is equals to change in momentum is equals to change in momentum. So Ft is equals to change in momentum. This symbol This is delta. This symbol is called delta. You see this symbol? It's called what?
Yes.
It's called delta,
Delta.
which stands for change. Delta means what? Means change,
Change.
okay? So which means now we can go ahead and say impulse. Remember, change in momentum is final momentum minus initial momentum, right? Do you remember that? Do you remember that?
Yes.
So FT is equals to what when you look at in the left, what is common? Mass is common, not so. Mass is what? So when you factorize out mass, you remain with V minus U, right?
Minus U.
So when I divide all through by T, I divide all through by T. This one will cancel that, right?
Yes.
I remain with F equals to M into V minus U out of T, right? I think that.
Yes.
From equation of motion, do you remember something like this? From equation of motion? From equation of motion, do you remember something like that? What is this?
Yes.
From the first equation of motion, right? Which is V equals to U plus AT, right? Do you remember this equation?
Yes, teacher.
Now, if I make A the subject, let's make A the subject. So which means if I make A the subject, we shall have V minus U out of T, right?
Minus U. Yes.
Now, which means this one is what? Acceleration. A is what? A is acceleration.
Acceleration.
A is our acceleration. So which means now the formula becomes, so it implies that our F is equals to M into V minus U out of T. But we have seen that all of this is what? Is acceleration, right? So therefore, our formula now becomes M what? MA. And that's the formula you have been using, right? Have you seen that?
Yes.
Have you seen? Where F is a resultant force. F is a resultant what? F is a resultant force, okay? M is the mass of the body. M is the mass of the body. Then A is the what? A is the acceleration.
Acceleration.
Now, what Newton did, Newton had to put these two concepts together, impulse and then change in momentum together. Then he came out with the law. He came out with the what? With the law, which is here. I think what I'm highlighting?
Yes.
So now Newton's second law of motion now states that the rate of change in momentum, it says that, can you write it down? The rate of change of momentum, the rate of change of momentum of a body, the rate of change of momentum of a body, the rate of change of momentum of a body is directly, add the word directly, okay? Is directly proportional, is directly proportional, directly proportional, the rate, let me write it for you, the rate of change, the rate of change of momentum of a body is directly proportional to the force applied, or to the force what? Applied, to the force applied, and it takes place in the direction of force, and it takes place in the direction of what? Force. That is it. That is what we call Newton's second law of motion. Newton's second law of motion. Are you together, members?
Yes.
Yes. Who can repeat it for us? I want someone to repeat it for us. I want to confirm. Who can repeat it for us? Sandra?
Shami.
Sandra?
Yes.
Sandra, can you state for us Newton's second law of motion?
It states that the rate of change of momentum of a body is directly proportional to the force applied, and
it takes place.
takes place in the direction of force.
And it takes place in the direction of force. Good. Thank you, Sandra. Thank you. Now, remember we are saying momentum, and force. All these are vector quantities, not so. All these are vector what?
Quantities.
They are vector quantities. We know that vector quantities have both magnitude and direction, right?
Direction.
So now we know that momentum, which direction does momentum take? Momentum takes forward. It takes direction of what? Of the velocity, right? Not so. So now, which means since they are vector quantity, so which means when you apply the force, what Newton is saying that when the body is moving, that rate of change in momentum, momentum, it must be brought because of the effect of the force. And when the body is moving, that body must move in the direction of the force applied. Are you together? Members? The body must move. The body must move in the direction of what? Force. But we know that there are some scenarios where this law may not be applicable. Okay? There are some scenarios where this law may not be what? Applicable. Like, take for example, sometimes if you are rolling a wheelbarrow, okay? You are rolling a what? If you are rolling a wheelbarrow, you find that instead of you pushing the wheelbarrow, it's the wheelbarrow pushing you, right? Have you experienced that?
Yes.
So in that scenario, do we say that you are moving in the direction of force? Are you moving in the direction of force when you are applying a force and you are not moving in that direction of the force of applied? Are you seeing that? So when you have the change in momentum must be in the direction of force. The change in momentum must be in the direction of what? Force. Momentum must be in the direction of what? Force. So now we are saying Newton's second law of motion enables us to define the units of force. And establish the fundamental equation of dynamics. That one, and that equation we have just derived it, not so. Have you seen how we derived that equation?
Yes.
Is there any question how we derive that formula? Is okay, right? We have understood how we have derived that formula, right?
Yes.
Good. Now,
Yes.
moving forward, we are saying according to Newton, second law of motion. According to Newton's second law of motion, we are saying that the force applied, okay, the force applied is directly proportional to the rate of change momentum, and the rate of change momentum is just given by m what? Ma. Now, this is according to the law. Now, when I remove the proportionality sign, okay, when I remove this sign, now, which means I will say force is equals to Km what? Kma, okay? Where K is the constant of proportionality. Where K is the constant of the what? Of the proportionality, okay? Are you together?
Yes, teacher.
Yes. Now that one now will take us to what is that constant called? What is that constant called? Okay. And now it will give us the SI unit of the force, the SI unit of the force. We remember we said if mass, we are saying if mass is equal to 1 kilogram, if mass of the body is equals to 1 kilogram, okay, and the body is moving at the rate of 1 meters per second squared, is moving at the rate of 1 meters per second squared. So it means now the SI unit and the force of 1 Newton is applied on the body, and the force of 1 Newton is applied on the body, which means our K, which is equals to F over MA, right? I think that when you make K the subject from here,
Yes,
you find
teacher.
that our K will be equals to F over MA. Yes. Now we are saying that if the force applied on the body is 1 Newton, so we will have 1 divided by the mass is what? Mass is 1, right? 1 times 1. So which means our K will be equals to 1. So which means now that's why we normally just write the formula as therefore our K force is equals to K MA. Remember now K, we got K to be 1, right? K is what? K is 1. So therefore our formula will just be K is force is equals to MA. I think that. Have you seen that? Members, have you seen that?
Yes.
Yes, very good.
Teacher.
Now we are saying the SI unit of force is called what? Newton. The SI unit of force is it?
Newton.
Newton. Then there's one thing I need to remind you. When you are writing the SI unit, and the unit is got from the name of a person, and is the name of a what? Is the name of a person. So when you are writing SI unit, you write that word in small letters. You write it in small what? Letters. So if you are writing Newton as a unit, the SI unit of force, okay, I think that. If you are writing in what, you write in small letters. You start with the small letter N. If you are writing as a unit, then the symbol in bracket you write capital N like that. Are we together?
Yes.
Yes. Very good. But if you are writing it as a name of a person, you start with a capital letter. Please, who is this one writing on my screen? Please, can you stop writing on my screen? Okay. Are we together, members? So you can go ahead and define what is a force. You can go ahead to define what is a force. You can go ahead to define what Newton is. Who can define what is Newton? Who can define as Newton? Define for me Newton. Newton of a force. Define for me Newton of a force. What is Newton of a force? Remember, when you are defining a unit of a given quantity, you start by giving that quantity. Okay? So you say Newton of a force, Newton of a force, okay, is a force. Are you together? You say is a what? Is a force. Which what? Which what? Which give a 1 kilogram mass. A 1 kilogram mass.
An acceleration
Of a body, and acceleration. An acceleration of what? 1 meters per second what? Squared.
Second squared.
Okay, that's what is it? Newton. Okay.
Yes.
Very good. Now there are some calculation there. Let's go and let's see how we can use this formula. Remember, our formula is F is equals to MA. That's the most important thing. That's the formula. Okay? So let's see how we can use that formula, please. Let's look at example number 1. Who has finished number 1? Who can take us through that? Who can take us through that?
A force 3 newtons acts on a body of mass 5 kilograms. Find the acceleration produced.
Lynette?
Yes, teacher.
Yes,
teacher.
can you take us through number 1, please?
A force of 3 newtons acts on a body of mass 5 kilograms. Find the acceleration produced.
So we start by collecting data. Let's start by collecting our data.
Let it guys.
We start by collecting our data. So what is the force? The force was given to be 3 Newton, right?
3 newtons.
What about mass? Mass is 5 kilograms, right? Not so. Members, are we together?
Yes.
Now they want us to find acceleration. So which formula are we going to use to find acceleration? So you come and say using F is equals to M A. Remember I said when you are doing calculation, in calculation, what is the most important? Formula, not so? Substitution, okay? Substitution. Then you must be accurate. Then you must be accurate. And you must be. So they want us to find. So you first make A the subject. So A is equals to F over what? A the subject. So A over what? Not so. So after that, our A is equals to the force which is 3 divided by the mass which is 5. So our acceleration is acceleration will be, we don't have that calculator. Now use what is on my screen. 3 divided by 5. We get 0 point. We get 0 point. 0.6. 0.6. Do we stop there?
No.
Yes?
No.
What is missing?
The units.
What is the unit?
Meters per second.
Meters per second what? Squared. Meters per second what? Squared. Are you together?
Yes.
Number 2. Do for me number 2. Do for me 2 and 3. I'm waiting for the answer. We have 10 minutes remaining. 10 minutes remaining. So can we do those?
We can't see.
Yeah? Can we do those? You cannot what? You cannot what?
See.
You cannot see the question?
No. You have seen.
Yeah. Are you getting that answer on the screen? Members?
Yes, teacher.
Are you getting that? Are you getting 72 Newton in number 2?
Yes, teacher.
Number 2 is okay, right? What about number 3? Go to number 3. Go to number 3. Go to number 3. Jordan?
Yes.
Are you working
Yes,
out?
teacher.
Are we together?
Yeah. Yes, teacher.
Okay. Alexandra? Alexandra?
Yes, teacher.
Are we moving together?
Yes, teacher.
Yes, Inachu. Inachu?
Yes.
Frida? Maya? Maya?
Yes.
Have you got the answer? Have you got the answer now?
Yes.
Okay. Nalokenge, what do you have?
Teacher, first give me a minute.
The answer is 3, right? Okay. Now,
Yes.
let's go to number 4. Number 4, that's where I want us to discuss. Number 4. Question 4. Question 4.
30 minutes time.
Now, in number 4, we have two forces. Two forces acting on a body or on a particle, but they're acting in opposite direction. Right? We have this one here, then we have another one there. So this is 6 Newton. This one is 10 Newton. The body is there. Mass is 5. Mass is 5 kilograms. Okay? So mass M is 5 kilograms. Now they want us to find the acceleration. So acceleration we don't know. But remember we said using F is equals to MA. Using F equals to what? MA, where F is the resultant force. Remember F is the resultant. F is the resultant what? Remember, F is the resultant what?
Force.
Force. What's the resultant force? What is the resultant force? Who can define first resultant force? So, resultant force, for those who have forgotten, resultant force is a single force. Is a single force acting. Is a single force acting on a what? Resultant force is a single force acting on a body. Okay? Are we together? Okay. Now, when you look at this one, they're moving in opposite directions. The two forces are acting in opposite directions. We have 10 Newton and then we have 6 Newton. So what would be the resultant force? So if they're moving in opposite direction, we get the difference, right? So which means our F will be equals to, the resultant force will be 10 minus 6 Newton. Okay? Which will give us, so the resultant force in this case is what? Is 4 Newton, right? In the direction of 10 Newton, in the direction of the 10 Newton force. In the direction of 10 Newton what? So that's our resultant force. Okay? So from F is equals to MA. So our A will be equals to F over what? F is equals to MA. Right? So our acceleration will be force, which we have as resultant force we have got 4. Our mass, which is 5. So therefore, our acceleration will be 4 divided by 5. 4 divided by 5 we get 0 meters per second.
8.
Are we together?
0.8.
Members, is that clear?
Yes.
Good. So I think that's why we are going to stop for today. Next time when we meet, we are going to look at Newton's third law of motion, okay? Okay?
Yes.
A quick reminder,
Yes.
a quick reminder, members,
Yes.
Yes.
is there any question? Is there any question so far? Is there any question?
No.
How was the lesson? How was the lesson? Was good, eh?
Good.
Yes.
Thank you. Thank you. Thank you for being good student too. All right. Now there's another concern. There's another concern. Because I've discovered that people are sharing links. When you join, people are giving the ID for the meeting. Don't share it with your friend, please. Okay? Are you getting me?
Yeah.
So if you want us to help your friend, please let the person call us. Let the person either call me or call Teacher Joseph, okay? So that we can help, but not you giving the link. Are you together? Are you together, members? Yes. So don't share the link. If you want to, if there's a friend of yours who want to join, let the person contact me or contact Teacher Joseph so that we can help him. Are you together?
Yes.
Now, assignment. I'm giving an assignment. I'm giving an assignment. I think that where we are having the test. I think here. I think this question here. I think this question here.
Yes.
Yes. Go and download the book and then try them out. Try them out, okay?
Yes.
All right. If there are no questions, then we can end there.
Yeah.
Maya, can you give us a closing prayer, please?
Teacher.
Yes. Yes.
Teacher.